Good morning, students. Hope you are fit and fine at your places. Students, as your revision tests are coming nearby, so today we are going to revise the chapter Gravitation, and the various topics that we are going to cover today are the gravity versus gravitation, universal law of gravitation, gravitational constant, Kepler's law of planetary motion, free fall, acceleration due to gravity, then variation of g with height and depth, then we will differentiate between capital G and small g, and last we will discuss the NCERT exemplar problems. So please listen the video carefully, watch it carefully. Before moving ahead, let's discuss the learning outcomes of the day. Students, after the completion of the topic, you will be able to differentiate between gravity and gravitation, state universal law of gravitation, then you will be able to derive the formula for gravitational force F between any two objects in the universe. Finally, you will be able to define gravitational constant. After that, we are going to discuss the Kepler's law, and you will be able to state the Kepler's law of planetary motion, define free fall, derive the formula for acceleration due to gravity, that is small g. Then you will be able to enlist the factors on which this g depends. And finally, you will be able to differentiate between small g and capital G. Students, as you all know, we are talking about the gravitational force, so we cannot negate the centripetal and centrifugal forces. So let's revise it. Both the forces help the object to move in a circle in the orbit. Okay? Centrifugal force, when the object moves around another object, then it comes into action and it acts away from the center of the object. It moves outwards. Okay, and when the centripetal force comes into action, what happens? Object when move in the circle, then centripetal force also comes into action along with the centrifugal force, and this is center seeking force. Object will tend to move towards the center as we have done. So here it is a tangent to the circle. Why are we discussing here the tangent? Because we know that whenever object is moving in a circle, then the direction of its motion is, velocity is along the tangent to the circle. So what's the tangent? It is the straight line that meets the circle at one and only one point. Here ABC is the tangent to the circle at point B. Okay. Then let's start with gravity and gravitation. There is just a fine difference between them. The force with which the earth pulls the object towards it is the gravity. Means जब हम बात करेंगे gravitational force between the earth and any other object, then we call that gravitation force as gravity. But between any two bodies in the universe, when we talk of the gravitational force, then it is called gravitation. So gravitation is the force between any two bodies in the universe. Okay. Universal law of gravitation. Students, as we have already discussed in the videos also, that what is this law? Let's look upon it again. Every body in this universe will attract every other body. If the body has mass m1, another body has a mass m2, both will get attracted due to the gravitational force of attraction, and this force is directly proportional to the product of their masses. If the mass m1, here mass m2, then force will be directly proportional to the product m1 multiply m2. Okay. Secondly, it is inversely proportional to the square of the distance between them. Means if the distance between the two bodies is r, then gravitational force is directly proportional to 1 by r square. Inverse relation. Okay. So we can write it in the mathematical form. First part says F is proportional to m1 multiply m2, and the second part says F is proportional to 1 by r square. So we will combine these two terms, and to remove this proportional sign, we make use of capital G. Here this G is constant of proportionality, and secondly it is called gravitational constant. ठीक है. यूनिवर्सल ग्रेविटेशनल कांस्टेंट, यूनिवर्सल मीन्स इट्स वैल्यू इज फिक्स एवरीवेयर एंड द वैल्यू ऑफ दिस g इज given by the scientist. ठीक है. Let's see how it comes. As we know that force is g m1 m2 upon r square, so we can find here g, capital G will be F, this r will go to the next side, F r square upon m1 m2 m2. So SI units कैसे लिखेंगे? We will write the SI unit of force, that is Newton, distance square, that means meter square, and the SI units of masses m1 m2 will be kg, so it will be kg square. तो denominator में है तो we'll write kg minus raised to power minus 2. And when this gravitational constant will be equal to the gravitational force, ये पेपर में आ सकता है क्वेश्चन. When both the values are equal, they will be equal only when distance between them is 1. इसको 1 ले लेंगे. And the masses of both the bodies is also 1 kg. So if two bodies have the mass 1 kg each and they are separated by 1 meter, then gravitational constant will be equal to the gravitational force, and its value is calculated by the scientists, and it is 6.67 into 10 raised to power minus 11 न्यूटन मीटर स्क्वायर पर केजी स्क्वायर. ये वैल्यू को अच्छे से लर्न करना है, ऐसे हम न्यूमेरिकल्स में यूज करेंगे. This value is universally constant. It does not depend upon any medium. ठीक है, everywhere in the universe it is constant. So that is why it is called universal gravitation constant. ठीक है. Let's move to the next. What are the properties of gravitational force? Students, just let us summarize all the properties. Number 1, gravitational force is weakest force. Because you can see at your places, if there are two pens closer to each other, दो पेन पड़े हैं टेबल पे, they don't get attracted towards each other. हम उनमें gravitational force को नहीं देख पाते. Reason is the gravitational force is the weakest force. बेटा, it comes into action only when it comes into action तो तब सब जगह पे होगी, but it comes in visible only when the masses of the object is comparable to that of the planets. बहुत ज़्यादा मास होगा तब ये gravitational force दिखेगी. Otherwise it is very weak force, weakest force. It is attractive always. It is never repulsive. Attractive, हमेशा attractive, एक दूसरे को objects को अपनी तरफ attract ही करेगी. It is the mutual force, means first body attracts the second body and the second body attracts the first body with the same force. And it is central force, act towards the center. ठीक है. It depends upon the two factors, that is mass and distance. ये आपका MCQ के लिए भी यहाँ important point बन जाता है. Gravitational force depends upon mass and distance. It obeys inverse square law. It is long range force, बहुत दूर तक एक्ट करती है, infinity तक इसका इफेक्ट रहता है. And it does not depend upon the any medium in the space. कुछ medium पे डिपेंड नहीं करेगी इसकी वैल्यू. It only depends upon the mass and the distance. Now, what is the importance of universal law of gravitation? बेटा, ये लॉ हेल्प करता है टू डिफाइन वेरियस फिनोमेना. जैसे इट हेल्प्स टू एक्सप्लेन द फोर्स दैट बाइंड्स द अर्थ टू द bind us to the earth, then motion of the moon around the earth, motion of planets around the sun, and also the tides formation due to the moon and the sun's gravitational force. So universal law of gravitation successfully explains all these phenomena. Let's summarize the Kepler's law of planetary motion. Number 1, it was every planet moves in the elliptic orbit with sun at one of the focus. Ellipse is this and elliptic orbit अंडाकार ये, और every planet is moving around the sun in the elliptic orbit. ठीक है. Sun is present at one of the focus. ये focus points हैं. Sun will be present at any one of the focus. Second says the line joining the planet to the sun sweeps equal area in equal intervals of time. Means sun से planet को जो line join कर रही है, it will sweeps equal area in equal times. Now when the planet come near perigee, here the distance between sun and planet is very less. So planet have to move faster so that the area it covers becomes equal to the एरिया इट कवर्स एट अपोजी. यहाँ पे ये स्लो रहेगा क्योंकि ऑलरेडी डिस्टेंस बहुत ज़्यादा है, तो एरिया बराबर रखने के लिए प्लैनेट विल बी स्लोअर एट द अपोजी एंड इट विल बी फास्टर एट द पेरिजी. तो हम यहाँ कंक्लूड कर सकते हैं दैट व्हेन द प्लैनेट moves in around the sun, then it does not have a constant speed. It speed up near the perigee and it slow down near the apogee. ठीक है जी? So let's move to the third law. Third law says that square of the time period of the planet around the sun is means time period means the how much time it takes to move in a one orbit, how much time it takes, that is capital T. Square of time T square आ जाएगा. It is proportional to the cube of the mean distance of planet from the sun. sun से planet का कितना distance है उसका हम mean निकाल लेंगे and that will take as r. So mathematically Kepler's third law says T square is directly proportional to r cube. And beta, using this law, Newton has formulated the famous universal law of gravitation. That is why we are discussing the Kepler's law. ठीक है? तो in the exam we are not going to ask the questions from Kepler's law. It is just for your understanding how Newton used Kepler's third law for the formation of universal law of gravitation. Next is free fall. As the name says, object is falling freely, and we know that whenever the object is falling, the earth attracts the object towards it because of the gravitational force, and whenever object falls towards the earth, under this force only the gravitational force is acting, then we say the object is in free fall. Please make it a point when object is falling under the action of gravitational force only, और कोई force ना हो, तब हम बोलेंगे object is falling freely या freely falling object, and the phenomena is free fall. Let's think, when object is freely falling, is there any change in the velocity? Yes. How it will happen? As we know, no doubt object is falling straight, so no change in the direction is there. But Earth's force is acting on it. Force produces acceleration, and that acceleration is because of the Earth's gravitational force. So we call that acceleration as acceleration due to gravity. So जब भी object fall करेगा, freely fall करेगा, then it will fall with the acceleration called the acceleration due to gravity, and it is denoted by symbol small g. ठीक है? acceleration due to gravity. वैसे हम acceleration को a symbol लेते हैं, small a, but acceleration due to gravity is denoted by the symbol small g. Since it is acceleration, so the units remain the same. That's the units is meter per second square. ठीक है? Let's perform the activity. It is given in your NCERT book also under the heading activity 10.3. Just take a sheet of paper and stone, drop them simultaneously from the first floor of the building. Now अब आप बोलोगे कि हमने drop किया है, that is they are freely falling. Actually what is happening? Whether both will reach the ground same simultaneously? We see that paper reaches the ground little later than the stone. पेपर पहले नहीं पहुंच पाएगा, स्टोन पहले पहुंच जाएगा. दिस हैपन्स बिकॉज ऑफ द एयर रेजिस्टेंस. ठीक है? ये फ्री फॉल नहीं हुआ क्योंकि देयर इज एयर रेजिस्टेंस ऑल्सो. एयर रेजिस्टेंस फोर्स की वजह से पेपर को ज़्यादा वो फोर्स मिलती है क्योंकि उसका एरिया ज़्यादा है. सो पेपर विल टेक सर्टेन टाइम टू रीच द ग्राउंड. सो ये फ्री फॉल नहीं है. फ्री फॉल कब होगा? देखो लास्ट में, इफ वी डू दिस एक्सपेरिमेंट इन द ग्लास जार from where air has been sucked out, पूरा fully vacuum is there, then this paper and the stone will fall at the same rate. Actually बेटा ये गैलीलियो की observation भी थी. गैलीलियो what he did was he took one glass jar और उसने बीच में से उसमें air को evacuate कर दिया. vacuum pump की help ली और बीच में से air was removed. What he observed was that if there is no air inside this glass jar, vacuum is created, then feather and the coin will fall with the same acceleration and they will reach the ground at the same time. It will not depend upon the mass. Acceleration due to gravity will be same. Both g लगेगी दोनों पे and it will not depend upon the mass. feather का mass बहुत कम है, 5 रुपये का. Comparative to feather it is more, but acceleration due to gravity on both will be same because acceleration due to gravity does not depend upon the mass. ये थी गैलीलियो की observation. So बड़ा पत्थर हो या छोटा हो, बड़ा stone या छोटा, both will fall at the same time when they are dropped from the same height. ठीक है? and when the condition is they are freely falling. So numerical problems में इस बात का हमने ध्यान से इसको यूज करना है गैलीलियोस ऑब्जर्वेशन को. Next comes acceleration due to gravity's formulation. Let's see the definition first. It is the acceleration due to gravity is the acceleration, constant acceleration when object is falling freely. Then that acceleration is acceleration due to gravity. Its value is 9.8 मीटर पर सेकेंड स्क्वायर. तो हम इसको 9.8 मीटर पर सेकेंड स्क्वायर को हम राउंड ऑफ करके 10 भी ले सकते हैं न्यूमेरिकल प्रॉब्लम्स में. ठीक है, वैल्यू 9.8 के आसपास हम इसको राउंड ऑफ कर सकते हैं. ठीक है डियर, फॉर द अर्थ इट इज दिस, नॉट फॉर एवरी अदर प्लैनेट इट विल, फॉर द अर्थ इट इज 9.8. याद रखनी है ये वैल्यू 9.8 मीटर पर सेकेंड स्क्वायर. How can we find the formula for G? Let us see. We know that from universal law of gravitation we have this formula, F is equal to G m1 m2 upon r square, and from the Newton's second law we have F is equal to ma. Remember? So here acceleration is acceleration due to gravity. We take it as G. If we equate both these formulas, we can get the formula for small g. See, mg will be equal to g mm upon r square, and this small m mass of object will get cancelled and g comes out to be gm upon r square. So from the formula it is clear that g depends upon gravitational constant, जो कि constant है, fixed value है. Mass of the planet, that is the mass of earth, वो भी fix है. Radius of earth r वो भी fix है. So g की value भी fix है on the surface of earth. ठीक है. Now how to calculate this value? As we know, mass of earth is this 6 into 10 raised per 24 kg. Radius of earth is 6.4 into 10 raised per 6 meters, and gravitational constant is 6.67 into 10 raised per minus 11 Newton meter square per kg square. By putting all these values in this equation, G equal to gm upon r square, you will get G as 9.8 meter per second square. And for simplifying the calculation, we will take it as 10 meter per second square. Now let's see how G depends with various factors, like G decreases with altitude, means if we move away from the earth's surface then the value of G will decrease. As from the diagram it is clear, when the object moves away from the earth, what will happen? Its distance will increase. The denominator का जो distance है between the planet and the object, it will increase. बहुत ज़्यादा बढ़ जाएगा तो denominator will increase, so value of G will decrease. So G decreases with height. Second is G will also decrease with depth. How? When we move inside the earth, no doubt the distance between the object and earth from the center, it is decreasing, but side by side बेटा उसका mass earth का भी कम हो रहा है. हम अंदर जा रहे हैं तो we will take this mass only into the consideration. So from the formula, here m will also change. So by calculation we find that G decreases with depth also. G कम हो जाएगी. At the center it will become totally 0. G is greater at the poles and lesser at the equator. अब क्या हुआ कि हमारी जो अर्थ है, as we know, it is not circular. It is not completely circular. It is flattened at the poles. ठीक है. Due to this, what happens? The radius at the equator and radius at the pole are not same. At the equator, it is more, and at the pole it will be lesser. So r कम हो गया. जहाँ हम बात करेंगे पोल की, तो at pole radius of the earth is smaller, so value of G will be greater. ठीक है. तो at poles value of G is more. At equator since radius is more, so denominator ज़्यादा है तो इसकी वैल्यू कम हो जाएगी. तो ये this question comes in the paper also. Why it happens? तो आपने रेडियस का कॉन्सेप्ट लेना है. रेडियस ऑफ एट द इक्वेटर इज मोर देन दैट ऑफ द पोल बाय 21 किलोमीटर्स. ठीक है. लेट्स डिस्कस दिस क्वेश्चन. व्हाई जीपी इज ग्रेटर देन जीई, मींस एक्सेलरेशन ड्यू टू ग्रेविटी इज मोर एट पोल्स than at equator. Why? Because at pole radius is lesser than that of the equator by 21 kilometers. So by using this inverse law, we know that G is inversely proportional to the square of the radius. So acceleration due to gravity at pole will be more than the acceleration due to gravity at equator. Actually at pole its value is 9.82 meter per second square. At equator its value is 9.78 meter per second square. And for simplifying we take the mean of these and averagely we take only the value 9.8 मीटर पर सेकेंड स्क्वायर. ठीक है, कैलकुलेशन में हम 10 भी ले लेते हैं कई बार. Let's differentiate now between the gravitational constant and the acceleration due to gravity, that is small g. First is the values. The value of capital G is 6.67 into 10 raised to power minus 11 Newton meter square per kg square. याद रखनी है ये value. But small g की value on the surface of Earth is 9.8 meter per second square. Secondly, gravitational constant is a scalar quantity, does not depend upon the direction. But gravitational force जो हमारी है उसकी वजह से जो acceleration आती है, that is acceleration due to gravity या gravitational acceleration, it is vector quantity. It depends upon the direction also. ठीक है, acceleration है ना. Then gravitational constant is remain constant everywhere. Universal gravitational constant है everywhere in the universe it is constant. But acceleration due to gravity varies at different places. ठीक है, planet to planet different आएगी values इसकी. For Earth it is 9.8. Then SI units of gravitational constant is Newton meter square per kg square, and for small g it is meter per second square. So students, I hope that you have we have completely revised this, and I hope you will revise it again and again. And let's see how much we have revised. Let's solve the NCERT exemplar problems. Number 1, what is the source of centripetal force? कहाँ से आती है centripetal force that a planet require to revolve around the sun? So कहाँ से आएगी ये force and on what factor does it depends? तो answer is the gravitational force main जो होती है gravitational force because of the masses of the object is the source of centripetal force. So gravitational force will provide the centripetal force that will help the planet to revolve around the sun. Now gravitational force किस पे डिपेंड करेगी? उसी पे centripetal force डिपेंड करेगी. It depends upon product of the masses, ठीक है, planet और उसका दोनों का, and also depends upon their distances, inverse square relation. So if this force becomes 0, what will happen? The centripetal force जो होगी वो नहीं रहेगी फिर, and the planet will move in the tangent direction. ये हम डिस्कस पहले भी कर चुके हैं. On the earth, a stone is thrown from the height h in the direction parallel to the earth's surface, and while another stone is simultaneously dropped from the same height. Which stone would reach the ground first and why? बच्चे, हमने सेम हाइट से दो स्टोन्स को ड्रॉप किया है. वन इज थ्रोन फ्रॉम द हाइट इन डायरेक्शन पैरेलल टू द अर्थ सरफेस, और दूसरे को सिंपली हमने छोड़ दिया है. दोनों ही ड्रॉप हैं, तो विल दे रीच एट द सेम टाइम? द आंसर इज यस, बिकॉज बोथ आर ड्रॉप फ्रॉम द सेम हाइट and their initial velocity will be same. 0 से शुरू हुए हैं वो, तो reach करेंगे ground पे same time पे, because small g will be same for both the stones when they are freely falling. Suppose gravity of the earth suddenly becomes 0. In which direction will the moon begin to move? Yes, we have done this. If no other celestial body affected, yes. अब gravitational force, gravity 0 हो गई है, तो centripetal force will also be 0. So there is no force to pull. ठीक है? So the moon will move in the straight line tangent to the circular path. जिस सर्कुलर पाथ में मून मूव कर रहा है उसी के टेंजेंट पे, उसी पॉइंट पे जहाँ पे ग्रेविटेशनल फोर्स खत्म हो गई है, उस पॉइंट पे मून विल मूव अलोंग द टेंजेंट. ठीक है. Two identical packets are dropped from the aeroplanes, one above the equator and other at the pole, near the pole, from the height h. ठीक है. Two packets are fall from the height, same height h. One is at the equator and one is at the pole. ठीक है. Assuming all the conditions same, will these packets take same time to reach the surface of Earth? Yes, याद है वो रेडियस वाली बात. रेडियस एट द इक्वेटर इज मोर देन द रेडियस एट पोल बाय 21 किलोमीटर्स. सो उससे क्या होगा, g की वैल्यू चेंज हो जाएगी. सो एक्सेलरेशन वैल्यू नो डाउट इट इज कांस्टेंट, बट इट डिपेंड्स अपॉन द radius also. So since earth is not completely spherical, it is flattened at the pole, so g is more at the pole than at the equator. So g पोल पे ज्यादा होने की वजह से पैकेट जो है it will reach the pole first and then it will reach the equator. So packet will stay in the air for longer when dropped at the equator. Earth is acted upon by gravitation of sun. Even though it does not fall into the sun. Why? अगर अर्थ उसको सन उसको खींच रहा है तो why earth is not falling on the sun? Why? Sun no doubt provides centripetal force to keep the earth in its orbit, but earth provides the centrifugal force. ठीक है, due to its motion वो move कर रही है तो centrifugal force उस पे लग रही है towards the away from the center and centripetal towards the center, and the balance of these two forces prevent the earth to fall on the sun. ठीक है. How does force of attraction between the two bodies depend upon their mass and distance between them? Students, this is the last question of the day. बेटा ध्यान से देखो, in this question actually indirectly it is asking for the universal law of gravitation. How does the force of attraction between the two bodies depend upon their masses and the distance? So we'll write the gravitational formula. F is equal to g m1 m2 upon r square. A student thought that two bricks tied together would fall faster than the single one. वही गैलीलियोस ऑब्जर्वेशन वाली बात, फेदर और 5 रुपी कॉइन. तो यहाँ पे उसने लिया टू ब्रिक्स टाइड टुगेदर विल फॉल फास्टर देन द सिंगल वन अंडर द एक्शन ऑफ ग्रेविटी. डू यू एग्री? तो डियर यहाँ एक्शन ऑफ ग्रेविटी हमें बता रहा है कि इट इज फ्री फॉल. So we will not agree with this. Since bodies are thrown from the same, they will fall with same speed irrespective of their mass, because acceleration due to gravity does not depend upon the mass. ठीक है? So g will be gm upon r square. It is depending on the mass of earth only, not the mass of planet. So this shows that two bricks जो हैं both will fall at the same time. ठीक है, कोई भी brick, two bricks will not fall faster than the single one. ठीक है. So students, this was all for today. I hope you have enjoyed and you have achieved all these outcomes. So let's check. You have achieved the difference between gravity and gravitation. Then we have also discussed about universal law of gravitation. So students, the Kepler law, free fall, we have discussed all these things. So please revise your concepts and so that you get very good marks. Thank you class. Enjoy and stay safe at your homes. Thanks again. Thank you.